Hello, I'm Norberto Castillo Garcia, one of the authors of the paper entitled Fuzzy Clustering for the Package Delivery Problem. One of the most common operations of package delivery companies, for example UPS or Federal Express, is to pack the products in trucks in order to locally deliver them to the customers. The products are generally packed in rectangular boxes of different dimensions. An efficient assignment of boxes according to their destination to delivery trucks must consider the minimization of the number of trucks required. Thus, a considerable amount of fuel is saved, and hence the delivery time and pollution are reduced. The main motivations to carry out the present work are the following. The clustering helps us to considerably reduce the complexity of the problem. This is so because we follow a divide and conquer approach. In particular, we consider to apply the Fuzzy-Simmons algorithm to the delivery locations. The delivery locations are geographically described by the latitude and longitude. Therefore, the locations whose latitude and longitudes are relatively close will be grouped in the same cluster. In this slide, we present the general framework of the Fuzzy-Simmons algorithm used in this study. The algorithm requires 4 parameters: the number of clusters, the data, a value of tolerance, which is generally set to 0.001, and the parameter n prime used to compute the centroids. In line 1, the algorithm sets the initial values of the matrix U in such a way that each column has exactly one entry whose value is 1. In addition, the algorithm ensures that no row contains only 0 values. The number of rows in matrix U correspond to the number of clusters, and the number of columns correspond to the number of delivery locations. Lines 2 and 3 start the current iteration and stop variables. In line 4, the algorithm enters into the main loop. The first operation executed by the algorithm is to compute the centroids of each cluster. Then, it computes the distances among the centroids and the locations. In the following step, the algorithm updates the matrix U for the next iteration. Then, in line 8, the algorithm computes the value of epsilon of each entry as the difference between the matrix U in the current iteration and the matrix U in the previous iteration. In line 9, the algorithm decides whether or not to continue iterating. If epsilon value is less than or equal to the tolerance, then the algorithm must stop. Otherwise, the algorithm has to continue. Finally, in line 11, the algorithm outputs the clusters obtained during the execution. This slide shows the application of the Fuzzy-Simmons algorithm to an instance consisting of 65 delivery locations. The instances used were generated randomly using a uniform distribution. We set the number of clusters to 5, and the resulting clusters were plotted into a Google map, each having a different color. As you can see, the delivery locations that are relatively close to each other are in the same group. That is, they have the same color. This slide shows the application of the Fuzzy-Simmons algorithm to a random instance with 140 delivery locations. We use again the same number of clusters. In this plot, we can also see the same clustering pattern as the previous instance. This slide shows the application of the Fuzzy-Simmons algorithm to an instance with 260 delivery locations. Again, we set the number of clusters to 5. As we can observe, the result of the clustering process is consistent with the previous instances. In this paper, we have proposed to use the Fuzzy-Simmons algorithm to the package delivery problem. The algorithm was successfully applied to the problem approach. We can visually validate the clustering process according to the distances to each other. The clustering will allow the optimization of the truck routes in the next phase. That's all for me. Thank you so much for your attention.